Welcome to Chapter 2, Chemistry, which deals with some of the math you're going to need to know for this course. And the first thing they show you is that you're going to be dealing with either very large numbers or really small values. So it's imperative to start learning about scientific notation. Scientific notation has three aspects. You have your coefficient, which always is a number between 1 and 10. You have the base, which is 10, and then you have your exponent, which tells you how you're going to move the actual decimal. This exponent has nothing to do with zeros. It has to do with the fact that if you're going to move this decimal, place it to the right or place it to the left. If the exponent is negative, that means your values could be normally less than 1, and you're going to move it to the left. If your exponent is positive, that means your value is greater than 1, and you're going to move it to the right. So I'll start you off with 10. You got to first convert this number between a number between 1 and 10. So that's why we always add a decimal after the first number. So it becomes 1.0. And since you're not moving it anywhere, it's just 1. And that's why the answer is 1. Now this becomes 1.0 once again. So you always put the number, you always want to put the decimal after the first number when you're going from standard to scientific to standard. Just like that. So going back to this one, 1.0, you're moving the decimal one place to the right. So notice that that's why the answer is 10. Let's do a negative 1 now. So here you're moving it one place to the left. So that's why it's 0.1. So once again, just to rephrase, it's all about the exponent. So 5.10, you don't move it at all. It starts at 5.10. Here, 5.1, you're moving it 1 to the right, so you get 51. Here you have minus 3, so you're going to be moving this 3 places to the left, and that's why you have 0.0051. So when we use some terminology, when we go from, say, standard to scientific, this is our standard. Standard is how you normally would write it, and scientific is when you use your base and your exponent. Scientific to standard, once again, this tells you how many places you're going to move the decimal. Okay. So there's lots of ways to calculate scientific notation, which you can read through on your own. But what I want to focus on is the calculator. With the calculator, when you use scientific notation, you want to find the EE, E, or EXP button, because most of the time you will be using a calculator to solve these problems. What you would do is you type in the number 1.53, and then you would push EE, E, or EXP. Sometimes it's second function, so you have to actually find it on your calculator. But these letters or variables represent times 10, so you never put times 10. So if I was going to plug this into the calculator, I would basically put 1.53, EE means times 10, and then just 16. And that's how you would do it. 1.53 EE to the 16th. All right, so we're going to spend a lot of time in units, and a lot of chemistry is just converting units. So you need to know conversions. And I'm not going to say you need to memorize conversions, but you need to know how to use conversions. So we're going to go through a couple of these to show you how it's done. Conversions aren't that tricky. So the key is to figure out what is the actual conversion. So to go, how many meters are in a kilometer? How many angstroms are in a milliangstrom? How many milligrams in a grams? You just have to basically find the conversion. So I'm going to show you a problem that you could do basically on your own. So let's go back to one as an example. We'll use this slide. All right, so if I said, I wonder how many meters there are in a kilometer. So imagine if the problem said, oh, look, you have 500 meters. How many feet is that? The way you do this, and the way you do every dimensional problem is, you start off with your initial given, 500 meters. And then you're going to multiply it. And when you multiply it, this is called dimension analysis. You want to get rid of units. So the unit you want to get rid of is always your starting unit, which is meters. So that goes on the bottom. The unit you want to end up with is the unit you're looking for. So this example is feet. So because you're looking for feet, you would put feet on top, and then you would put meters on the bottom. You then would figure out the conversion. 1 meter equals 3,280 feet, and then you plug in your conversions. 1 meter equals 3,280 feet, and then you just solve the problem. Like I said, so much of chemistry is just simple dimension analysis. That's important for you to start learning how to do this little dimension analysis trick. Remember, the unit you want goes on top, and the unit you want to get rid of always goes on the bottom, and then you find the conversions. So here's another example of some unit conversions. And you can convert anything. As long as you're given the conversion, you could do it with any number. So a copper pellet has a mass of 231 milligrams. What is this mass in grams? All right. So first you have to know the conversion. And the conversion you either have to know or it has to be given to you. So here's an example. That's the conversion that's given to you. So 1,000 milligrams equals grams. So here are your conversion factors. So you start off with your given. Remember, you put the unit you wanted to convert to on top. So I'm looking for grams. So grams would go on the top. Milligrams. So because I want grams, that will always go on top. Because this is the unit you're starting with, that's the one that goes on the bottom. Because eventually that's the unit you want to get rid of, so that crosses off. And now you plug in your conversion. You just got to find for every 1 gram equals 1,000 milligrams. And that's the whole concept. So that's it. So like I said, dimension analysis, it's not that tricky once you figure out what your actual conversion is. Here's my conversion. So once again, I start off with my given. Here's my given. I have 326 centimeters. This is my dimension analysis, this division bar. And remember, the whole concept is to get rid of a unit. So the unit you're given, we'll turn that to blue, is what you want to get rid of. The unit you want, we'll turn that purple, pink, it goes on top. You do the units first, and then you plug in your conversion. For every 1 inch, it's 2.54 centimeters. Now you just do the math. So 326 times, in parentheses, 1 divided by 2.5, close parentheses, and you solve, and that's basically the whole problem. Boom, just like that. 1 inch. So looking for inches, so the answer is 128 inches. Here's another example. I'll just give you a whole bunch of examples. The speed of light in a vacuum is 3.0 times 10 milliseconds. What is the speed in miles per hour? It's the same concept. You just have to look at each unit separately. So you start off with your given. Once again, here's my given. Now, when you write your units, write them like a fraction. Don't write them like on a straight line. That's a mistake that people make. This is a fraction, means this is my numerator, this is my numerator. This way you could do them individually. So your first step is to convert meters into miles. So you have to be aware of like what unit is the conversion for what unit. So I'm starting off in meters. I want to convert that to miles. And I give you the actual conversion right here. So you put meters on the bottom, miles on top, and then you figure out your conversion. 1 mile equals, and notice how meters crosses off. Now this is the next step, and this is the important part. You create another dimension analysis, and now you want to get rid of seconds. So to get rid of seconds, you put seconds on top because that's how you get rid of it, hours on the bottom, and then you find the conversion for that. So basically you're doing it in 2 steps. You're doing the 1 unit, and then you're doing the other unit. And once again, the goal is you always want to place the unit you want to get rid of opposite. So I should say, if this is the numerator and you want to get rid of it, you want to place in the denominator. Just like if this is the denominator, if that's the unit you want to get rid of, that goes into the numerator. So that's why you have these ones with 2 units are a little trickier. Volume also gets a little tricky because there's many different ways to find volume. So here's the trick with volume. If you're going to cube a volume, like cubic decimeters are 1 cubic meter, you have to cube the entire, not just the unit, but also the value. So how many cubic decimeters in 1 cubic meter? So I know there's 1 meter and 10 decimeters. So if I was to cube this, I would put it outside parentheses. So I know 1 meter cubed equals decimeter cubed. You cube both. 10 times 10 times 10 is 1,000. Decimeter cubed is 3. 1 times 1 times 1 is 1. Meters 3. So when you have a conversion like this, when they're asking you to give like to cube something or square something, you gotta do it both. So how many cubic centimeters are in 1 cubic meter? So the first thing you do is don't focus on just centimeter or meter. How many centimeters on the meter? Okay, and now you put this in parentheses, and you cube everything. So this becomes 1 meter cubed equals, and 100 times 100 times 100 is 1 million centimeters cubed. And that's how you do it. All right, so that's kind of what I wanted to show you when you were doing your dimension analysis. I think everything else is pretty straightforward. It's just pretty much the conversions that are pretty tricky on these problems. So keep practicing, and I'll talk to you real soon.